Okay, we're back. It's been over 2 weeks since part one of this four expression, these iterations, but I'm really excited to get back at it. It's been a busy couple weeks, and yeah, this is something I've been thinking about a little bit, and I'm excited to make progress, keep making progress on the project. Some of the times with side projects like these that are hard and demanding, you don't really just have the motivation to work on them. You kind of lose it. It comes and goes, and one of the skills I'm working on to this day is finding the energy to work on something more rewarding like this, even if it's challenging, like at the end of the day. So anyway, that's a little bit of an aside, but here we are. Let's see what we can do. I think I remember I ended last time in the Kojin phase, confused about the type of something. Then I realized right afterwards watching that the issue here with this program is we were looking at the type of this second one. So let's make our lives easier and have one for expression in our program we're testing, so we can't get ourselves confused like that. And it'll just be this one. And then the other thing that wasn't answered is last time I thought it would be really cool to be able to distinguish between a for loop here that yields values, so that would produce another array if it were run on an array, or one that doesn't produce any values, that produces unit. And I actually think it would be really cool to do something right here. And I was thinking about the words do and yield. So we could have for it in x is do, and of course we can skip it in. So we could have for x is do. Of course you wouldn't do this because this isn't side effecting, but maybe you would print. And then we could have for x is yield, it times it, and then that would be an array. And so I think I want to start there and distinguish between the two, because I think desugaring them is going to completely depend on whether we're producing an array or not. The other thing too that I want to call out is we have a lot of work to do in the typer to desugar this. We don't want to do all of this in CodeGen. That's something I've learned not to do, right? Is make CodeGen see these really complex constructs and then like expand all this code. One, because then your binary size would actually get really huge if you always did that. But two, this is the kind of thing that should be desugared into the while loop that you would have to write otherwise. So I'm excited to desugar that. I'm not sure how we're going to deal with like variables we create during desugaring, and if they're going to like collide in scope with like user variables and that kind of thing. So I'm wondering if I'm going to get stuck there. But anyway, that's where we are. So let's get right into the parser and sort of reorient a bit here. So what we had was this for expr, and we have the optional binding. I think we're just going to put a boolean here for now, and no need to get more complicated than that. Pub is yield. It's not just yield type, because if yield type is unit, then it'd be an array of units. It's really the difference between making an array and not, which is saving the allocation, saving all that. So is yielding, which is confusing. I would see that and think control flow or something, and so we'll probably need to change this. Maybe I'll just go ahead and do a little enum. So we can make this enum copy, and we'll just do loop type for expert type yielding do. Yield do. I have mixed feelings about this. My first instinct was to reach for a bool. This feels a little early, but also I really didn't like the implication that this still kind of implies that it's kind of about control flow. But okay, we're never gonna get anywhere. We worry about that kind of thing. So let's go down and think about parsing this. So what's nice is we don't have to start from scratch. We're already parsing these, and we just need to think about where to insert this. So it comes right before the block. So we expect an expression that needs to be an iterable, and then we expect a block. Let me put this Maybe over here where it's usually going to be blanker. Sure. Okay. And right here, yeah, let's look for these keywords. Oh, shoot. We don't have do and we don't have yield, so sorry about this. Maybe I'll fast forward this. Maybe I won't. Maybe I'll just make you enjoy the grind with me. We could try to Vim golf this. Minimum number of keystrokes. But the problem is now I'm thinking about optimal Vimming, and I'm definitely going to make a mistake. So there's that. I'm still gonna do it just for funsies. So that takes all the fun out of it, doesn't it? So I think in the last couple weeks, Copilot got way better at knowing what I just did, like my last few inserts, my last few keystrokes. Because previously, when you would do something higher up in the file and then come down a few hundred lines, it's just predicting based on what's around here. It really didn't seem to know what I was doing, my current task, which is super important. You switch files, you're probably going to call the function you just wrote in the other file. You're not going to do some unrelated refactoring, right? So that's an interesting aside, I think. And I keep forgetting if I did do yield or yield do. So keyword do yield. Is binary, is prefix, is postfix. We forgot to implement these last time, so I'm just looking. Okay, this looks good. Okay. So we're going to expect, we can't just expect any keywords, so we're going to do let keyword type expert type keyword self dot. I don't even know how to call next because for so long I've been just working at a higher level in here, calling my expect functions. It's keyword, right? Or token, eat token. It's eat token with an expected kind. Oh, we could just peek. Okay, let's... So I have peek. Do I just have next? Self.tokens.next. Yeah, I think I just want next. Because it's kind of rare that I actually do this, that I want the next token no matter what, and I still want to advance. I guess if I peek here, then when I fail, the error can point at not the thing after the thing that wasn't a keyword, but right at the thing that was supposed to be a keyword. I could achieve that just by like handling it better, but let's peek. And then we can say if, and then, you know, maybe Copilot will be useful here. If it's a yield, okay. Let's add this just to see if that will turn it not green. What is the green? Unused result. Okay, so if it's a yield, then okay, so it wants to fully finish, and I don't want to do that. I just want. Now, the reason it's doing this is because I didn't do this. And if I had done that, it probably would have spat out something more like this. Okay, and we can make this a result. So if we produce a result from this let, then we can just question mark this. You know, for anyone who's not super familiar, look at this type hint here. This is currently a result, so it can fail, right? It can fail with a parse error here, where we expect a yield or do keyword. So we have this question mark. Watch that type hint. It goes straight to for expert type. That's really nice, like kind of type-driven programming. I like the inlay hints sometimes, for sure. you have to be careful because you come to think of this as part of your code, but it's not. You know, when you commit this, when you look at this diff, these types aren't here. If they're really important to you, you should add them. And they can also get in the way, but anyway. So here are for expr, and we just want to add our type. I just want to add it in the correct spot. It's still called is yielding, so sorry for everyone who's been, if anyone's been yelling for the last 5 minutes or so that that's still named is yielding. Maybe we test this and we just dump the expression for now. Make sure we parsed correctly. So first we'll have a yield, and that's going to be cargo run. We don't have to run the program because we know it won't compile anyway. Okay, well, I already know we didn't advance. It's so funny how just seeing an error immediately tells you. I didn't even look at the error. I just, seeing an error triggered a pattern in my brain that caused me to think of what could have gone wrong. It's interesting how long someone might look for a bug if you told them there was, but there actually wasn't one. For like a torture technique you could employ on programmers. Okay. Why am I doing this before the block? Oh, I guess it's just one line and it just got lost. I'm sorry. There we go. The block comes after the keyword, of course. Okay, we parsed. And we got down to here. Cogent for expr. So let's fix our display because we're dumping it here, right? But we can't see it. So that's in the typer. That's our typed display. So this is probably expr to, it's probably display expr. Yeah. Whoops. I don't like this line wrapping, but makes it much easier to read. Spare a little bit. Yeah, that's so much better. Okay, we don't really need the terminal. Let me do this. Let me just make this full, and then we'll just switch to the terminal sometimes. That's a little bit less claustrophobic too, isn't it? Okay. Well, let's go down to the bottom where for expr is, and if or for expr. This is our typed representation, not the parsed one. So we can imagine the type is on here. But at this point, well, it doesn't just become part of the result type. We still want to know what kind it is, I think. Yeah, this is really interesting because I don't want to hand this off to CodeGen because it's so complicated. I think that by now, I mean, do we just generate a while? So if we were to not even have this and just handle it all in desugaring, then what sort of a while loop would we generate? So this is the version, while version, for version. Turn off Copilot. I think, at least I think I did. I also pressed, nope. There we go. So this would be, and this is where I am worried if there's a variable called I and I just like splat this into the, desugar this code straight into the type checking phase if it's gonna mess things up. So anyway, while I is less than x's length. Block it val it equals, so it would be variable decal x is at I, add it to scope, block, and if it's, and that's it if it's a do. If it's a yield, then we're also going to have val res of type array of, we couldn't even write this code because we don't yet know what type this results in. Well, okay, no, I do know, right? I'm pretending I'm desugaring. So let's say block is it times it. So I come back up here and I would say, okay, that's array of int. Let's do it, sorry, it's greater than 0, so it'll be a different type than what we started with. So that's going to be an array of bool. That starts off empty. Let block expr val equals block exprs, which happens to be it's greater than 0, right? And then we're going to res.push. So we have an additional creation of an array. We have this binding, which needs to happen anyway. We're already doing that. We have attaching the result of the block to a local variable and then pushing it. Do we just pick really random names? Because really this is what we should pass to CodeGen. And maybe we just need another representation, a lower level representation that isn't, we got our fully typed repr, and we probably would want it to have the full for expr, and then we want something lower. It's maybe just not LLVM. I can't decide if I want to just concede and do it in CodeGen, because that's kind of where we are. We don't have a lower representation, or if I want to do this desugaring thing. I haven't really done this. Let's try desugaring it, because I know I could do it in CodeGen and it would just be wrong, the wrong abstraction, so just a lot of code. And I've spent too much time in CodeGen anyway. So let's try desugaring, which would mean we don't really have this. It's just going to become a while. And then, like, if you were to dump your typed AST, you're going to see the while. You're not going to see this. Now, we could have this, then we could have a lowering phase where we transform them. I just don't have one of those yet. And I don't really want to add a phase right now. Okay, let's do it in CodeGen, because I don't think I can add a phase tonight, and then see. And then if we need anaphase, then we'll do that, and we'll try desugaring maybe as a second system, second solution type of thing. So we'll just reuse the type from the parser. Typically, you'd have your own data types here in the typer that are different because you have different problems to solve here completely. We'll just do this. We'll just copy it right in. The result type is going to be dependent on this though. So if for expert okay, if it's a do, what's wrong with this? Oh. That's funny. In my head, by making a copy, it certainly already had eq, which is kind of not how that works. That to do is still valid. Yeah. Now, why did I decide we can't just do this here? Oh, because then we wouldn't even have captured. Yeah, when you like dump the typed AST, it would just be an ugly while loop. That's probably not a very good reason not to do it here, to be honest. So if we do it here, then we're going to really hard branch if it's a do or if it's a yield. Because we just have a lot more work to do if it's a yield. If it's a do... Okay, well, that's the other thing we could do. We could say if it's a do, then it's a desugared while loop. And if it's a yield, because now there's a lot different things that play with the types, then it's its own expression. That doesn't leave any less work to do in CodeGen though. CodeGen still is going to get handed one of these and need to make the array and do everything like that. Let's go straight into CodeGen. I think that I don't think what I'm doing is wrong worrying about this stuff. I think this is right. But let's put a pin in it and worry about the do version. So we'll go to CodeGen. Let's see. Where are we at with cargo run? Yes, so we want to dump. We want to correctly dump. Sorry, I want to be in the typer. This doesn't implement display. Sometimes I want Copilot. Those aren't my types. Yeah, because I turned it off. Forgot everything. Why is it mad? Okay. So now we'll run that. Yeah, so I messed up my file a lot because I wrote garbage in it. Okay, well, the main thing is that we see a yield here. Maybe we don't need that space. No, I removed the space from the row. 'Cause we just printed a space. Okay, for it and x's yield. It times it. Okay. Do. So squared should be of type unit. Of type unit! I skipped over the type last time. And if it's yield, the type is array event. Well, look, we've achieved something. All right. Code gen for expr. Oh, sorry, having trouble getting here. Okay, code gen for expr. So if we should match, so we get the exhaustiveness. For expr type and typed for expr is confusing IntelliJ. Yield, unimplemented, code gen for yield. Do, not bad. You know what? No. Up there. Okay, okay, okay. So we need to insert a variable. We've already done the binding. So there's a binding in the scope, but that doesn't help us. As we go through the statements, we're going to see this, and we need to actually generate the alloca instruction for the stack local that will point at it. And then we'll just push it in self.variables. Yeah, I really want to implement it in terms of while, because if we go to CodeGen for while, there's a lot going on. Well, okay, it's not that bad, but we're basically just doing this. And I'm not trying to implement loop unrolling or anything. You know, for iteration, you could unroll and stuff, but you need size hints, and that's not the thing. So I'm almost like trying to desugar here and then call this. All right. I would basically at this point I would copy paste the implementation of while loops here and then start to edit it, which feels kind of bad. Okay. I think I'm convinced to desugar it at the typed AST level. So we can leave this here, because we may not even produce one of these. So typer for expr. Okay, and the other thing too is it's going to be a lot of work to implement this for all of these types that we allegedly support. I really want to focus on just the array for now. All right, let's do it. So, step one. Okay, well, we don't want to desugar it till it is type checked. I just want to produce this and then, yeah, desugar it later. Okay, because I think things actually get so different for each of these types we can produce, I don't want to throw this code away, but I kind of want to just for on optionals and just to do these away and then move the control flow such that this is the result of the function and get rid of this down here, and then we'll focus on just array. So we can kind of do this. This might just be a type error at this point. Whoops, need this. For on string. Could okay. And then, yeah, result type is unit. And we could come up here and for do, see what I'm getting at, and then we can do and then we can do array. Let's try do just for now. So we're not going to produce one of these. We're going to produce a while loop, a while statement. Oh, but that's interesting because our whiles aren't even expressions. So we'll need to do like a block with a while in it because that is an expression. So that's fun. We would need to do that. We'll need to do that for the other path anyway, because where we're going to put our local variable. Okay, let's try this. So first thing we need to do, we need a variable definition for it. Is that right? And the initializer is going to be an array index operation. where the base is the iterable expr. The index is going to be our counter, be a valdef variable. Bear with me. Variable expr, yeah, of our counter variable. And this can be counter variable. Okay, the name is the binding ident. Come on, you can do better than that. Type has to be an int. Right, we're initializing it actually. Is mutable true. Owner scope. This is the body. Yeah, inside the body. So we're basically injecting code here. We'll see how this works. If this ends up really not feeling nice, or if this ends up nice. I'm not sure why it's so upset right now. The whole thing is just... Can we just... That's nicer, isn't it? Okay, this is some non-owner scope would mean root. Okay. Oh, okay, that's not, yeah, so, okay, that's why Copilot did something different. Counter, I want like a UUID. I wonder if every AST node had a unique ID, we could do that. Counter for, and then yeah, we could do the exact token it starts on. That's pretty funny. Global for counters. That's terrible. All right, you know what? One expression for now. As def to signal our intent. Counter unique. Something to make it unique. So our value, this goes inside the block. We're just making it right now, so that's okay. Let final block equal block dot clone. We own block, right? Yeah, we own you, so we can just make it mute. Body block dot statements dot what do? Do you in place? Anyone know? Prepend the val def to the body block. I think Copilot's off. Copilot instead of Google? Maybe? Okay, insert with index. Insert element position index shifting. This is, obviously slow, but we can do that. So now the first thing, well, we need the counter def as def 2. Well, do we even need an actual expression there? Or like an actual variable? Yeah, I suppose we do. This is crazy. And then thinking, when do we increment it? We increment it at the end. In my example, I don't think I did increment it. Yeah. Obviously, we can't. Oh, and an early return would return from the whole function. Maybe it's fine. Maybe it's not that broken. Let counter def the val def for the counter variable. Yeah, it's an integer literal. Where do we want to say it exists? Yeah, we can say it exists there. We could just say it exists in the body block. It's a more accurate location. These locations shouldn't matter though, because nothing should go wrong from here. We've type checked already. This should be pretty infallible. So what we're writing here, if anyone's lost, we're writing. Oh, these need to be declared outside. Okay. Okay, so this is actually what happens. So to desugar this, it's this. We create a block. That's frustrating. That's not what I wanted you to do. We're going to create a block in which we're going to do these things. And since it's our own block, we can name things what we want. No, but if inside here they used I or res, we'd be toast. So, well, I don't know. We'll see. But the point is that these statements don't go in the loop, but they go inside our block. So we're going to make a block. It's not the body block. So we can't actually have evaled the block yet, by the way, because oh yeah, we can. Because it'll still type check fine because we've added everything that's in scope. We just need to add the statements for code gen. The question is, will this block type check before we've injected these things? And yes, because none of these instructions actually, or expressions, refer to our hidden variables or our injected ones. Only our statements will, that will go at the beginning and the end. It's getting crazy. Yeah, we can just define it each time. So this actually does go in the block, but the counter doesn't. and eventually the outer array won't. What's wrong with index op? Base index result type span. It just doesn't feel right, you know, but it's fine. We'll see what happens. The valdef does go, and then append the counter increment to the body block. I'd rather guide it like this. Wow. How does it know? I mean, every field. So it is an add. It's an add of 1. Let's be really careful here. Yeah, and we can actually print this out and check it, which will be nice. In fact, our current Cogent and Cogent while will do, because this will end up being a while. Okay. So it's like this, and not this version. Although we can't go ahead and put it in a val that we just discard, but really, it's just this. We shouldn't crash in Cogent because we're just generating. No. What we're doing right now is we're not actually wrapping it in a while. Oh, we have to generate the actual. So our block, let for expert block equals typed block. It has a counter def. Later it'll have an array def if we're building an array. Let for expert scope. It's not the body scope. Let me just go up and make sure I haven't created a scope. No. We added a child for the body. And this is going to be wrong. The body needs to be a child of... We need to bind before eval of the body. That is true. That's wrong. That's wrong. This is where we'll eval the body block, and it's going to be added. It's going to be child of the 4x per scope. What I'm doing is this. I'm making this block, creating a scope for it, and then putting this body, and it's actually going to be the block of a while statement that I create. So we haven't even created. This is add child scope. and the variable ID here. Can we go ahead and create this? Yeah, okay. Once we have this scope, then we can make the body scope because it's going to be a child. But it's going to be, there's going to be one more because we need a while. I mean, the body scope will just be the scope of the while statement, actually, now that I think about it. So that's just correct. That's just the scope. Because this is the body block, and it's also the scope of the while statement. This doesn't go in the scope of the while statement. It's outside of it. Okay, I didn't make the binding variable ID. Yeah, we can make this stuff before we need it here. The valdef doesn't really need to be made till we make our scope. So this is our 4xper block. I kind of want to make it. All right, what all goes in there right now? Just the counter. Okay. It's spinning a little bit, but I think this is good. Well, maybe it's terrible, but I think it will work. And then by the time we eval the block, we need to be sure. Yeah, that's fine. It doesn't really depend on any of this what we're doing. We're doing this for code gen. So we just need to make an actual while statement. Counterdef while statement. We'll append that. So we're finally making our while loop. The condition is a binary op. The block is not the 4xper block. The block is body block. So that comes later. All right, so we'll like fan back out. Now that we made the body block, we'll make our while statement. And then span. Sure. The spans are a mess. I wonder how people do this. I wonder how people do this for real. I'll go check Yacht after this and look at like desugaring. Maybe because their target is C++, it's so high level that yeah, it just doesn't matter. Having a really high level backend like C or C++, kind of cool. Well, those are quite different, but you get what I mean. Okay. What's wrong with this? Oh, you don't need to be boxed. Okay. And then your binary op. And this is while it's less than the length. Thank you. So less, it is a bool. Left-hand side is our counter variable. The right-hand side, I wish. How do we get the length of the array? It's a function call, isn't it? Array lane. We actually have to get the function ID for the length for this particular generic array. Like if it's array int, we need the length function for array int. Oh, jeez. Okay. But anyway, args is a vec. And yeah, so the argument is the iteree. It's not guaranteed to be a variable expr. This just needs to point, to our array. So the issue is, yeah, if it were, then you would just say x's. But if I did for it in 1, 5, 9, then this becomes while I is less than, right? We haven't evaluated that yet. So we probably need to put it in a local. We probably need to be like let iteree equals. And then we do have a variable ID. I think that's right. How else do you refer to it like stably if you're going to do this like desugared approach? So this wants to do iterable variable ID. Fine. So there actually are two things. There's the counter, and then there's let the iteree variable. Name iteree. Yeah. And the scope of these is the 4x per scope. Of both of these. You got to do that first, dude. And this is another variable def in the same vein as this one. Just initialize to the iterable expr. We already did. Okay. And this iterable def. So what we just did is we just put this line here in our desugared version so that we can say this here. Okay? I actually don't hate that. It has like the same, the only thing I'm concerned about is the same thing I'm concerned about with everything, which is the names of these variables colliding with user code. Maybe we could do like a parallel scoping thing where they're just completely different universes, so it doesn't even matter. Because maybe that's exactly right, because you would never want to refer to this. So maybe we could just flag them as internal. And then when we're doing scope lookups, if it's user, then we just don't look at internal things that are scoped internally. It's interesting. Okay, our array index. Which means we get to use this. So this will be the same thing. This will be another variable expr. This is iterate variable expr. And so is this. So every time I want to say iterate in the generated code, I'm just cloning this guy. That's all. Okay. So now we actually can pass this. We have our call. It takes one argument, the ret type, array length. It's just the int type. The span is whatever. Maybe I'll just put like 0, 0 for the spans for this stuff because you don't expect to see it rather than cluttering the code. I'm not sure if it just said like empty span or internal span. If this just said everywhere, internal span or something, might be a little bit less distracting. Okay, so we need the array length function ID. Let array length function ID. So we have self.functions. An array length is going to be in here, but it's going to be a generic one. And like we're in charge of specialization here. Now we can go get we can look it up, which is never what this was intended for. Or we could make it like we typed it and look it up that way. It's really painful that this is where we're stuck. If I were... So if I were to manufacture a checked call, resolve function call within this scope, can I do this? Right? Like I want to call my own code. So resolve function call, and now I have to make a fake parsed call. We'll make it like a name length. Okay. Type args, some. Yeah, that's actually right. Yeah, that actually works too. That's the... Let's just make it the actual iterary for expr dot iterable expr. Yeah, because it needs to be a fun call arg anyway. Yeah. So fun call arg. Oh, and these need to be fun call type arg, which has name. Yeah, they can be named. So none. Oh, it's supposed to be a typed expression though. No, I can't just say int. Oh, well, we could infer it. Okay, we could pass none here and have it infer the type. This is what I don't want to be doing, is manufacturing AST stuff. Just borrow that. Now I'm wishing array length was a built-in. Expression found. Oh, it needs to own it. That should be fine. What's this upset about? Oh no, yeah, right. None, the scope we're calling this from, it can just be the scope of this entire call. That's fine. It doesn't need to be any of our inner scopes because we didn't define array length anywhere in here. Expected, a borrowed function call. Expression from box. Parse. You just want me to deref it. Okay, that works after cloning. Okay, well that's horrible. I hate that I had to do that. This is the thing I feel the worst about, to be honest. I don't even know if it's going to work. We're gonna expect right for sure. There you go. Array length function not found when desugaring a 4 expr. Yeah. Well, the good news is nothing that I've done is specific to array yet, except for that part where I just reached in. Oh, and then array index. Yeah. You probably just want to write it again for optionals. String is going to be really similar. String I should have done instead. To be honest, because it's easier. Well, I'm about out of gas. We can't parse because we got made up code again. We're back to our harder version here. Function not found, length in scope. Okay. Oh, okay. Let's not forget that we didn't add our while statement. So our for expert block statements, can you guess? Yeah, I need to push the while statement. Oh, no, you're very mutable. I really need to push that. So this is as if I did length on this expr. Function not found, length in scope. Hey, at least the span looks kind of right. That's fun. No, because if I'm doing it this way, then I want it to be as if I called array colon length. Like this. Right? Because I'm not doing it as a method call syntax, so it doesn't know. Not yet implemented. Typer 1879. Eprintln self dot display block. Yes, please. Let's just do expert to string. What? Bear with me. Forgot about Rust. I don't even know what I'm writing anymore. Oh. Well, look at the code we made. Counter. The iteree is 159. While counter is less than length iteree. Val it is an int. Iteree counter unique. It times it. Counter unique plus 1. Close. Close. Huh. I think that's right. And it type checks. It'd be cool to delineate these with like synthesized, you know? It'd be like synthesized, user code. Ding, ding, ding. Like, you know? But wow. That's pretty good. That's pretty good. Now, we're failing to code gen because I never actually code gen these. Yeah, we do. We don't need to return it to an Alica. Like, this is just that. How long has this been here, too? We, yeah, pulled a fast one there. All right. Now that we've implemented blocks, cannot code in generic function length. Oh, no. Okay. So do I have to call, get specialized function for call? I don't want to call this. But this, oh, I should call this instead. Like, because also, what if this is the first time we're encountering this type, an array of this type? Then we need to go through this machinery. Okay. I feel both worse and better. This is the call. inferred or passed type args. So, type param. Oh, it just takes type ID and ident. That's kind of nice. Because we can say that we know the type we need without having to pass the type expression. Yeah. No, it's ident. And yeah, we can actually hardcode that because we know that array space array length uses the letter T. So that's terrible, but wonderful. No, ident. Inferred or passed type args, vec. The generic function ID. Oh, really? It needs that? Okay, never mind. So I need the previous call too. Good thing it only borrows the call. If we did the this expert thing, we wouldn't need the calling scope. Why is it so angry? Wait, it all went wrong here. No, that's what. Oh, I'm trying to name function parameters in Rust. Well, we might need a helper for this. Or we could stash this away somewhere when we make it. The generic one would be easy to find. Anyway. Synthesized array length call. You know, it's so funny. I'm faking a call so that I can put the function ID in to fake a call. Could I just make... Yeah, I want to just call eval function call. That's what I want. Because I'm already faking this. Duh. Array length call. Wow. As long as you're willing to make a fake AST node, I mean, but it's, yeah, I mean, everything we're doing here is synthesizing code, so maybe it's not, maybe my instinct is wrong that it's wrong. I don't know. Okay. That's array length. So now it is as if they typed array : length right there. And we'll get the behavior that we would get, I think. Well, it built. Let's make it do something. Give ourselves some space. Let's print it times it. Yeah? So val squared is just going to be of type unit. Okay, so that's actually really close. Oh, now we have to finish. So what was that? An infinite loop of ones, which is 1 times 1. So hopefully that's happening. Where's our increment? Counter increment statement. Body block. Oh. I shouldn't blame Copilot because I accepted it all. But this is just an expression. This is not an assignment. Type statement expert. And because it was statement, I was like, yeah, no, assignment. We need to assign. This is great. This is our right-hand side. You feel? Our destination yeah. It's this. It's what it's saying. We don't have a reusable variable yet for our counter. And though we probably do it in the comparison. Variable expert. Yeah, so we could just come down here, counter variable expert. Programming this way is funny. We're debugging the code now. Where do we make counter variable? Up here. This expert doesn't have its scope in it. That's like not part of it, so we can safely define this up here and then just use it. Destination counter variable expert. So this should look a little bit better now. We're doing an assignment. We're doing an assignment to counter variable. I don't know if it's better to just use into for all of these. It's weird that assignment just contains a boxed assignment. Ah, span. Okay. Sorry, I used it. I need to clone it here. I don't technically need to clone it at its final use. Eh. Do we want to look at the LVM before we run it? 12581. Where's the hello world coming from? 12581. Well, we're not collecting into an array, but I think we see the path because we're synthesizing this code. It'll be pretty easy to synthesize one more statement. In here, we just have to do this, and then we just have to do this. Make sure this is an assignment to eval so we can push it, so we don't, run each line twice, or run the inner code twice. So this obviously only works with index-based arrays and counters. Like, it's completely specific to this situation. Nothing really general about it. But, let's say we had type classes. Then, like I talked about last time, instead of checking if a type is iterable, alright, so we should probably... we desugar the for do expert into a while loop, synthesizing a few local variables in order to achieve this. I think these are broken scoping wise and will collide with user code currently. To handle arrays. Okay, that's good enough. Anyway, so up here above, before we synthesize all this insane code, we were checking if a type was iterable, right? And that's a hard-coded thing. But we have everything we need that could traverse a bunch of impls and figure out if it's iterable, right? And if it is, then what we could do here, instead of hard coding, injecting this this mutable counter, we could, inject a call to iterator, right, on the thing that we know is there. And then, this approach would generalize. We just might not be generating, a local integer counter. We might be generating a call to iterable and to iterable.next and that kind of thing. So, yeah, don't be afraid to implement something simple or silly. Me doing this way doesn't mean that I don't understand how iteration might work with type classes or something more powerful, right? It's just me trying to wrap my head around something to start with, right? You just need to build from somewhere, and I got a lot of positive feelings right now, like with this 12581. That's really neat. We can work from here. Yeah, we've got a lot of really ugly code. There's no mechanisms in this code base to make it easy to synthesize code in this typer. But imagine we move this to a new file, we make an explicit desugaring phase, and we create a bunch of helpers, like, creating a local variable. And this could be reduced to one line, like a little call to make var, and you have a little DSL, and suddenly you can desugar lots of things and do some powerful stuff. So that's where it could go, right? But don't be afraid to just write some code that does something. Because until you do that, you're not really going to know what you don't know. Yeah, I guess I'll stop there. At some point, I'll start adding the commits to the end of these videos. I like that Andreas Kling does that throughout his videos. He's always committing. But no, I'll just leave it there. I'm too tired to even commit. It's been an hour and 35 minutes of talking while coding, which I'm not used to at all. It's much, much harder. So thanks for watching. I hope you enjoyed it. Good night.